Children, in this video we are going to learn about imperfection in solids. What is meant by imperfection? Imperfection means that is not perfect. Nothing is perfect. So generally in nature, according to the law of nature, nothing is perfect. So crystals need not to be perfect. They always found to have some defects in the arrangement of their constituent particles. These defects affects the physical and chemical properties of the solid and also play an important role in various processes. Such a way, in crystal there are many defects, we can say. Number one is point defect. Number two, line defect. Number three, interstitial defect. Number four, volume defect. Among the four defects, we are only going to see about point defect. Point defect means when the deviation or irregularity exists from ideal arrangement around point in an atom, then the crystal is called as a point defect. Line defect means that ideal arrangement, deviation from the ideal arrangement exists in the entire row. That deviation is called as line defect. So, point defect divided into three types. Number one, stoichiometric defect. Number two, non-stoichiometric defect. Number three, impurity defect. Stoichiometric defect. Stoichiometric means if the imperfection in the crystal are such a way that ratio between the cations and anions are same before and after the defect, that we are going to see. First, stoichiometric. It is divided into two types. One is Schottky defect, another one is Frankel defect. What is Schottky defect? Schottky defect mainly occurs due to the missing of equal number of cations and anions. Missing equal number of cations and anions. We can see the diagram in the book. See, this is the NaCl crystal. Cl, Na, Cl, Na, Cl, Na, Cl, Na, NaCl, Na, like this going on. See, Na, here Cl is missing. Likewise going on. See, here Cl, Na is missing. So, missing one Na and missing one Cl. Equal number of cation and anion is missing. That is called Schottky defect. So this defect does not change the stoichiometry of the crystal, losing one cation as well as one anion. So does not affect the stoichiometry. Stoichiometry means equal number. So ionic solids in which cation and anion, they are also almost similar in size. So presence of the large number of Schottky defect lowers the density of the crystal here. Here lowers the density in Schottky defect. It lowers the density, missing of equal number of cation and anion. That is the important point. Similarly, the size of cation and anion are of almost equal size. These 3 points must be well known. Schottky defect means missing of equal number of cation and anion. Then next one, it lowers the density of the crystal. Third one, the sizes of the cation and anion are of almost similar size. For example, given in a book, vanadium monoxide. For vanadium monoxide, the calculated value is 6.5 gram per centimeter cube. But the actual experimental value is 5.6 gram per centimeter cube. Calculated value is 6.5, actual value is 5.6. So this indicates that 14% Schottky defect occurs in VO crystal, that is vanadium monoxide crystal. So presence of a Schottky defect in the crystals provides a simple way by which atoms or ions can move within the crystal lattice. So this and all for Schottky defect. Now Frenkel. Frenkel means the atom will not miss from the crystal lattice, but it occupies in the interstitial site. That is, leaving from the original site and occupying in the interstitial site. For example, you can see the example in the book. See, here AgBr, Br, Ag like this going on, Br, Ag plus is missing. Here also one Ag plus is missing. See, missing means it is not leaving from the crystal, occupying some other place. See, in the interstitial place. See here, leaving from the original site and leaving the vacant place here and occupy some other place. Similarly, this one leaving from the original site and coming and occupying in some other place. This is called as interstitial defect, occupying dislocation of ions. So Frenkel defect arises due to dislocation of ions from its crystal lattice. So the ion missing from this lattice point occupying in the interstitial position. This defect is called as Frenkel defect. Here the size of the cation and anion differ in size. For example, AgBr does not affect the density of the crystal. In Schottky we have learned it affects the density of the crystal. Here it does not affect the density of the crystal. Only 3 points. Occupying in the interstitial position, leaving from the original site, occupying in the interstitial position, then size differs, does not affect the density of the crystal. Density of the crystal.